Oh my goodness. This is one of those mini lessons that just blows my mind every time. Gives me goosebumps, like math goosebumps right here. Right on the arm, if you can't see it. And I'm not gonna hold up the camera so you can see my goosebumps, but they're there, trust me. We're gonna prove that e to the I times pi plus 1 equals 0. What? Arguably, e to the I pi and 1 and 0 are the 5 most important numbers in math. You could argue that there's some other numbers in it that are very important, obviously, but they're pretty darn important, all of them. And we're going to prove that e to the I pi plus 1 equals 0, or that e to the I pi equals -1. It's the other way of looking at it. Either way, let's do it. So how are we going to do this? We're going to do this with power series. So first we start out with the fact that e to the x we know is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus x to the 5th over 5 factorial, and the list goes on and on and on in that pattern, x to the n over n factorial plus dot dot dot. Okay, now what we're going to do is what we've done in the past, which is insert in values into this Maclaurin series for e. So I'm going to now take that and write it as e to the ix. So how do we evaluate ix, and why are we doing that? Because this is essentially I times pi. You could also just plug in I pi right into this. I'm going to do it as e to the ix, do it in steps. So that would be 1, ooh, okay, plus, you're going to see why I do it as ix too. I think it makes it a little clearer. Ix plus this will be ix squared all over 2 factorial plus ix cubed all over 3 factorial, just plug in everything in, plus ix to the 4th all over 4 factorial plus ix to the 5th all over 5 factorial plus dot 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 ix to the nth all over n factorial plus dot dot dot. Okay, so what the most important part is in all this is this. So I'm going to stop writing that general term from here on out. What's the important part? Check this out. E to the ix then simplifies down to 1 plus ix plus, this is I squared x squared. I squared is -1. So we're actually going to get, and I'm going to erase that negative right there. We'll get rid of that thing. So let's get rid of that negative, or that positive, and write it as a negative. So it's going to be minus x squared over 2 factorial. Plus, is it? Well, not quite. I cubed is the opposite of I. So it's minus ix cubed all over 3 factorial. Okay. I to the 4th is 1. So it's +1, x to the 4th all over 4 factorial. And then we repeat the cycle here. I to the 5th is going to be, well, what's that going to be? Plus I. So that'll be plus I x to the 5th all over 5 factorial. Now, what's the importance of all of this? The importance of it is you got to see a pattern in here. It's tough. So I'm going to write this over here. We need a little more room. E to the ix is equal to, I'm going to rewrite it in a different order. Do you all see the I terms and the non-I terms? We can split them up. So I'm going to write it as 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus, and that keeps on going. So those are your non-I terms, plus, and now here are your I terms. I'm going to take out I from all the terms that we have here. That's going to be I times x minus x cubed over 3 factorial, whoa, pretty cool, plus x to the 5th over 5 factorial. Now, if you don't see it yet, you will in the next step. That keeps on going on and on like that in that pattern. What pattern is that? That's cosine. Isn't that sick? I think that's so cool. So I'm literally jumping in my seat. So e to the ix is equal to cosine of x. That's what that is. Plus I sine of x. That's sine. What? That is so clutch. Now at this point, all we have to do to show that we're equal to -1, or show that this is -1, so +1 is equal to 0, is now evaluate in pi into this. So e to the I pi is equal to cosine of pi plus I sine of pi. Whoa. And what's the cosine of pi? -1. What's the sine of pi? 0. So that's I times 0, which is just 0, which is equal to -1. That's awesome. Goosebumps every time, every single time. We showed that e to the I pi is -1, therefore e to the I pi plus 1 is 0. Just some of the more magical things we can do with Maclaurin series. And I thought that was a really, really neat way to kind of just end up this lesson on power series. And I know it's on differentiation and integration, but now that we're really good with seeing the manipulations, I thought this was the time to insert that into our studies. All right, y'all. I'll see you in the exercises. That was exciting. Peace.